Are you looking to accelerate well-architected reviews and save countless hours on manual assessments? Hello, everyone. My name is Shoeb Bustani, and I'm a Senior Solutions Architect at AWS. And I welcome all of you to my session, Accelerate AWS Well-Architected Reviews with Generative AI. In this session, I will talk you through practical ways Amazon Bedrock can support your architectural assessments, right from identifying potential areas of improvement to streamlining your review process. When you are building systems at your organization, how confident are you that those systems are being built using the best practices for the cloud? And this is where AWS Well-Architected Framework plays an important role. It helps you understand the pros and cons of decisions you make while building these systems on AWS. By using the framework, you learn architectural best practices for designing and operating reliable, secure, efficient, cost effective, and sustainable systems in the cloud. The AWS framework is based on 6 pillars that helps you build stable and efficient systems on AWS. It is a set of questions and design principles that are spread across these pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Alongside the pillars are AWS well-architected lenses, which provide guidance with a focus on a specific industry or a technology domain. For example, data analytics and financial services industry lenses. To evaluate the health of your workload, you essentially answer a set of foundational questions based on the framework, pillar, and lenses. In addition, to align with your own organization's operation plans, internal processes, or maybe industry, you could define and manage custom lenses. Creating a technology solution is a lot like constructing a physical building. If the foundation is not solid, it may lead to structural problems that may undermine the integrity and function of the building. Similarly, if you neglect any of these 6 pillars, operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability when architecting technology solutions, it can become a challenge to build a system that delivers functional requirements and also meet your expectations. On the contrary, if you incorporate these pillars, it will help you produce stable and efficient systems, allowing you to focus on functional requirements. There are 3 parts to Wafer framework. First is the content. So the framework with design principles, pillars with the questions and best practices, along with the white papers that gets published on AWS website. Next is the self-service tool, the tool that uses the framework to carry out the reviews of the workload in the form of question and answers. This is embedded within AWS Management Console as its own dashboard. It allows you to generate the PDF reports for improvement plans. And then you have got the data that you have from doing the reviews, including metadata and identified improvement plans. As organizations expand their cloud footprints, it brings challenges and opportunities to scale when it comes to adhering to well-architected framework. For example, manual reviews may become time-consuming and resource-intensive. Different teams may apply the well-architected principles inconsistently across the applications or across the teams. Keeping pace with the latest practices may get tricky, especially with the new services and features being released continuously. Do remember, Wafer is a continuous activity, and the scaling reviews for numerous or large architectures can become difficult. To overcome these challenges, builders like me at AWS have come up with a vision to accelerate AWS well-architected framework velocity and enterprise adoption by leveraging the power of GenAI and provide organizations with automated comprehensive analysis and recommendations for optimizing their AWS architectures. The proposition here is to use the Wafer content, tool, and data with generative AI to drive well-architected assessments. And this approach brings multiple benefits to the enterprises. For example, the rapid analysis cuts the amount of time spent on Wafer reviews, resulting in time efficiency gains. The AI powered analysis ensures consistent and thorough evaluations and reviews across workloads. Optimizing resource allocation and reduced manual efforts result in increased staff productivity and also shift left mentality, which result in overall cost saving for the organization. And you can perform more frequent reviews over time, refining future assessments and improving feedback loops. There are other benefits too as well. So we talked about scalability in the beginning. So ability to run multiple reviews simultaneously would be a good thing for the organization. Also, taking it to the next level, interactive exploration through chat interface to dive deeper into the assessments, asking follow-up questions, and getting a better understanding of the recommendations. This interactivity enhances engagement and promotes thorough comprehension of the results. So when it comes to building such a system, you would using GenAI, prompt-driven approach appears as a trivial choice. The prompt is your interface to the model, and crafting the right prompt is crucial for the output generation. So prompts are similar to decision process of human beings by learning from analogy, by tweaking the inputs or the prompting of the words, you get the desired output on completion. And the slight changes or tuning to the prompt can have a significant impact on the outcome. Of course, it takes trial and error and also an artistic flair to it as well. But effectiveness also depends on the how model was trained. When it comes to prompt engineering, there are multiple types. You have a zero-shot prompt or prompt by instruction, which uses LLM out of the box. It allows you to language models to perform on the task they have not been explicitly trained on. Then you have one shot or a few short prompts. What it means in here is that you provide one or more pairs of problem and solution pairs as short as to the input prompt. And this helps to guide model performance. And then you have chain of thought prompting. It addresses multi-step problem-solving challenges in arithmetic and common sense reasoning tasks. It generates intermediate reasoning steps, mimicking human review of the human train of thoughts before it provides the actual answer. In principle, you would think that in the current context of well-architected framework, you could create a series of prompts from the framework questions and sequence through LLM to solve the problem. That sounds straightforward. However, there are limitations with prompting. They have a poor memory, work with very limited context, and then and it relies on accessing external knowledge sources to complete its task. And this is where the retrieval augmented generation or RAG or architecture offers more. Retrieval augmented generation or RAG is a process for retrieving facts from knowledge bases to ground LLMs with up-to-date, accurate, and insightful data supplied in the prompt. It has three stages. In the retrieval, in the retrieval stage, the relevant content is fetched from the external knowledge base or data sources based on the user query. The retrieved context is then added to the user prompt, which goes as an input to the foundation model as part of the augmentation. And then the response from the foundation model is now based on the augmented prompt. Now that we know the basic functioning of RAG, how does it actually work? First, you need to optimize the data for RAG to work, and it is done as part of the data ingestion layer. First of all, the data is sourced from the relevant data sources. Then that data from the data source is chunked, wherein the large pieces of text are converted into small segments, then stored in the vector database using embedding models. Then during text generation workflow, on receiving the user query or question, a semantic search is done and retrieved passages into bracket R are ranked and parsed as a context that is augmentation or augmented into bracket A into an FM model, which in turn generates a response complete in the G aspect of it. So, based on what we have seen so far and learned so far as part of this session, we are now talking about an improved approach wherein we take the content data and tool and combine it with Amazon Bedrock and knowledge bases for Amazon Bedrock and LLM to drive well-architected assessments. Building on this approach, I'm excited to share that we builders at AWS have developed our comprehensive one-click or few-click deployable solution to facilitate and expedite AWS well-architected process. It uses workload documentation. It means you can upload your own solution architecture documents or technical design documents to the application. It uses mainstream inputs data sets, so it accepts a PDF file format that you can convert your documents into and upload it to the application. It uses or ingests AWS well-architected documentation from AWS public website into the internal knowledge base. And it's extensible. You can extend it to include your own organization or industry review standards using custom lens. So entire stack is created as infrastructure as a code with AWS Cloud Deployment Kit, CDK in short, that you can deploy with one or few clicks. And there are a number of artifacts that get created or used as part of the stack. So we are using Amazon Bedrock with Anthropic Cloud LLM for the LLM. And then we are using open source serverless as the Amazon Bedrock knowledge base. Alongside, we use DB, and which is our core database for storing the review run information. In addition, we use Amazon SQS EC2 instance, which hosts the Streamlit front-end application. In addition, there are other services such as S3 buckets and Amazon Cognito for user management. The heart and the core of the reviewer is based on AWS Lambda and step functions, which manage the Wafer analysis runs. In addition, we use cloud for distribution with ALB and initial web rules for you to improve upon. Let's see how it works. For the demo, I have created a fictitious payment solution for a fictitious company, any company that receives and processes payment files to drive its downstream systems and ML workload. The Wafer Accelerator sample does not require the documents to be in any particular format or a template for its working. However, the quality of the documentation that's uploaded for assessment is an important factor. Detailed architecture documents will result in better inferences and hence better assessments. However, in this particular example, I have created a solution architecture document for the fictitious solution that I described earlier. And this is a pretty comprehensive document. It's 37 pages long, which is typical with these kind of documents. And we will provide this as an input to the Wafer Accelerator tool, which would review and provide architecture assessment in the context of this document and the Wafer-driven knowledge base built from the AWS Well-Architected Framework public documentation. This is the landing page for the Wafer Accelerator sample. So I have already created a fictitious user. So I'm going to log in using that user. Before I proceed any further, the user that I use to log in is part of the Cognito user pool that's provisioned as part of the CDK stack. All you need to do is go and create or provision the users in that user pool. So this is the welcome page. So you have got a few options in here. The most important one are new Wafer review and existing Wafer review links. They are available here as well. So I will start with a new Wafer review. There are two analysis types in here. One is a quick one, and the other one is a deep with well-architected tool integration. So quick mode is, as the name implies, is a quick mode wherein we club all the questions for a particular pillar into a single prompt to speed up the inferences. But it's a good starting point for the submitters. For example, if I am a solution architect If I want to submit an architecture document for review to potentially architecture review board, then I would like to mark my own homework and I could come to this, generate a quick Wafer assessment and see how far I am from or my documentation is away from the well-architected best practices. And the responses or the assessment in this particular mode resides completely within the application. And then you have got the deep with well-architected tool integration. This is as the name implies, is a deep review wherein we draw inferences for each and every question separately from the selected pillars. And it's also integrated with the AWS Well-Architected tool. It means on completion of your review, you do get the review output in the application, as well as you have got a workload that gets created in AWS architected tool. And we'll see it a little bit later. So in the interest of time, what I'm going to do is going to create a sample, create a quick review, and I'm going to call it Wafer Accelerator Quick Demo 2. Okay. Give it a description. Then you can select the environment, industry type. So in this particular case, because it's a payment solution, I'm going to mark it as financial services. I'll enter a fictitious name for the reviewer and select the Wafer lens I would like it to be reviewed. So right now, at the time of demo, we are supporting 3 lenses, the core AWS architected framework lens, and then data analytics lens and financial services industry lens. So for this particular demo, I'm going to select AWS Well-Architected framework. The user is created by field is populated by the username I used to log in the application. And now I could go and select the pillars I would like it to be for it to review. So I have the option to select all the pillars. However, you don't have to select all the pillars. You can only select the pillars you are interested in. For some of the customers, if they are interested only in security and reliability, they could select those pillars. But for the demo purpose, I'm going to select all the pillars and then upload the document I mentioned earlier. At this point, I have populated all the fields. I'm going to create a Wafer review. And as the message says, it has been created successfully. So if I go back to this, okay, it has commenced the processing. So I would let it complete because it takes a little while for it to complete. But in the interest of time and for showcasing purposes, I've already created a few demos in the past. So let's select one of them. So this is the metadata that we entered when creating this particular review. So the first step is to create a solution summary. So we use the document that has been uploaded and use the GenAI to create a solution summary. It means the reviewers don't have to read the entire document, or not all the reviewers need to read the entire document. They can read the solution summary. And this is followed by by questions for all the pillars that have been selected. So for this particular one, I had selected all the pillars, and hence you can see all the pillars in the tab. So starting with this, you have got the question at the top. This is followed by a quick assessment, and then it tells you which best practices have been followed, recommendations, and examples. In this particular case, document did not have enough information on this, and we have revised the prompts in such a way that if it can't find the relevant information, it calls back and says, we don't have enough information to provide the assessment. So coming back to the recommendations, it gives you a list of recommendations to improve your whole architecture, followed by risks that GenAI has identified and citations from the AWS Well-Architected framework documentation. And it does it for all the questions in the pillar, as you can see. And it does the same for other pillars as well. So in this particular case, it did identify the best practice from the well-architected framework in the document, which was to use separate workloads using accounts. And in here, it gives you citations and risks. And it does it for all the pillars that were selected for the review. Let's have a quick look at the deep review. The deep review works in a similar fashion. You have got the summary or metadata information, followed by solution summary. Then it responds with the same kind of structure, answering all the questions for the selected pillars. One thing that it doesn't do is the risk, because we want the well-architected tool to reduce the risk based on the choices that get selected. Otherwise, it's pretty much the same. Okay. And it does it for all the pillars. And let me select the quick demo tool, which is just kicked off. So that's still in progress. But as you can see, it has already created the solution summary. So it's created a summary. Now it's trying to answer individual questions. And it's taking a little bit of time to do that. Another feature I wanted to showcase to you, let me select the deep. I can select any of them. Let me select the deep tab. Okay, so we talked about ability to chat with the content and to understand, better understanding, have a deep dive of the review that has been carried out. And this is where this chat functionality is super helpful. So let me select the solution summary. So I would like to check with the content that was in the summary. So for example, I could say, which AWS regions are used? So as you can see, this information isn't there already. So it should be able to deduce this very quickly. So that's fine. This is good. But if I say which AWS EC2 instances are used, then of course this document, this information is not there in the summary, and hence it's not able to find. So I could switch to the document and ask the same question again, and let's see what it does. Because this has been documented in the solution architecture document, it's able to pick up that information and provide me that data. So this is quite a handy feature, and this you can do it for all of the sections that have been generated. Okay. So one of the things which I mentioned earlier was integration of the deep mode with the well-architected tool. So let me go to the well-architected tool in the AWS Management Console and show it to you. So this I'm back in the console after sign out. So if I go to the workloads, I can see a workload and the name matches with the review that we had carried out. So if I search for it, I can see it's there. Oops. I'll do the other way around. I'll select it from here and search it there just to prove the points. Yeah, so it's essentially the same. So if I click on this, this was purely generated by the Wafer Accelerator, the sample itself. We didn't do anything. We just created a review in the application, and this is what it has done. And if you see, what it does is it goes in and creates a workload, answers all the questions, or try to answer all the questions, and then it creates a milestone for it as well. This was a baseline version that was created in GenAI, and you could start to build on it as part of your human review process. So I could go in there. There's an I want to show you an interesting feature. So I will go in there and I will look at the review. So in the very beginning, I told you that you need to answer a set of foundational questions as part of the review. And each of these questions typically have a number of choices underneath. So this is not something I've done. What we have done is we asked the LLM to say, hey, when you're doing an assessment or trying to answer this question, can you also answer in terms of or select the choices that are applicable based on your assessment? So these tick marks or these choices were actually done by the LLM itself. And as you can see, not all of them have been selected, and it does it for all of them. And the good feature or another feature is that the population of nodes. So you get the assessment in the application, but at the same time, the generated assessment is also populated in the node section, as you can see. And it does it for all the questions for the pillars. So let me go back to the review. So what I could do in here is go back to that and generate a report. Okay, so this is the report which I've generated from console. So if you look at this, it has made some choices based on the GenAI assessments. And as a result of that, and does it for all the questions. So going back to the console. So if we look, the choices have resulted in a number of risks in response to the choices that GenAI thinks are applicable or have been implemented. And as a result of ruling out the ones which have not been selected by GenAI, the tool has generated risks. So if I go and click on that, I can see those risks underneath the individual questions. So just to summarize, what I did was I went in, I uploaded an architecture document, I carried out a deep review, it, and after a while it created an assessment in the UI, as well as it has created a well-architected workload with a milestone that you can use as part of your human review process. Let's go back to the presentation. Let's see what's happening behind the scene. You've seen the UI now. This is the overall architecture for Wafer Accelerator. So if you recall, we looked at the basics of RAG architecture. And the first step is to do a data ingestion. So as part of this, what we do is we download the files, the PDF file format from AWS public website, put it into an S3 bucket, and use Amazon Bedrock knowledge base and ingest it into that. And the way it works out is the embeddings are created and they are stored in Amazon Open Search for Serverless, which acts as the vector database. So the embeddings are stored within the Open Search Serverless vector database. And this is done as part of the CDK deployment itself. So you don't have to do it separate unless you want to update to a later version of well-architected framework in the future. So the second part is which I just showed it to you. So we have developed an application using Streamlit, which runs on an EC2 instance, and it's front-ended by application load balancer and CloudFront. We have integrated the WAF with the initial set of rules which you would like to enhance based on your requirements. And then you have got the Amazon Cognito user pool. So if you recall, I log in the application using a fictitious user, but I had to provision that user. So that pool is created as part of the IAC, but you need to provision the users. So once the document is uploaded or submitted for review, it gets uploaded to an Amazon S3 bucket and an S3, and the application sends an SQS message out to trigger the Wafer review. This message, SQS message, is received by a Lambda function, and that in turn invokes the Wafer reviewer with step function, which is the heart of this reviewer. And if it happens to be a a deep review, in that case, what it does is at this point in time, it goes and creates an empty workload in the tool. The next step in the process is to get extract the document content. For this, we are using Amazon TextRack. And once the data has been extracted, it goes to step 6, which is about invoking retrieve and invoke APIs. So this is where the query generation happens. And we'll look at it in a little bit more detail in the next slide. But the idea in here is to retrieve the relevant embeddings based on the question in context, and then augment the query, the prompt also that we have developed with that information and the uploaded document content, and ask the LLM to answer the question. So let's take an example of the first question from the security pillar. When this is being reviewed, first step in there is to find the relevant data from the knowledge base for this particular questions, and all the passages that have been found are then ranked based on the relevance, and then this is added to the context as a context in the query, which is passed on to the LLM. The review progresses. The step function keeps on updating individual questions within the tool if it's a deep review. If it's not a deep review, the information is stored purely in DynamoDB. In case of deep, it's stored in both the places. The next step there is to refresh the screen, as you're saying, and I was checking the status. So the users can always refresh the screens to check the progress of the reviews. Then I showcase you the chat functionality, wherein I went in and asked a few questions and it answered it for me based on the content that was generated by the review. And it also created a milestone in the well-architected tool. I showed it to you earlier, and that becomes a starting point. It could become your starting point for in the human review process. So this is the overall architecture for Wafer Accelerator with numbering around it. Let me show you a couple of things there. So in terms of resources, we have created a blog in here. So I've co-authored that blog with my colleagues, Brijesh Pati and Rohan Ghosh. We have also released this Wafer Accelerator sample under AWS samples. It means if you want to explore more, you can read through the book, which provides a lot more detail than the demo. And then you can download the samples, explore that. So let me show you the blog very quickly. So this is the blog. I've shared the link for that. You can have a look. And this is the AWS sample, which has got a lot more and detailed information on how to go about deploying and exploring this sample. So this is a blog. I just showed it to you. So before we conclude, let's have a quick recap. We started with AWS Well-Architected framework, the pillars and lenses, scaling opportunities as you expand your cloud footprint, and how generative AI could provide answers for some of the scaling opportunities for the reviews. And I showcased you the Wafer Accelerator, which demonstrate the art of possible when it comes to reviewing using Gen AI. So this brings me to the end of this presentation. I thank you all for joining this session.